Alright, we talked about these two examples last video, and hopefully this will be the last video. Just as with exponentials where we had base e, in logarithms we have two special cases. Log function with base 10 are called common logarithms. 10 is important because our numbers that we use are decimal system, meaning they have 10 digits, right? Which correspond to the 10 fingers of our hand and so on. So base 10 is what we're familiar with. And so we give it a special name. Which means if no base is written and it says log, then you can assume the base is 10. An example of this naturally occurring is our perception of loudness. Perception of loudness, B, of a sound with intensity I is given by this formula 10 log I over I naught, where I naught is, it's called the least possible sound that we are sensitive to hearing. So it says find B for a sound which has intensity 100 times that of I naught. So P is going to be 10 log 100 I naught over I naught. Now because there is no base written, by rule that means this is base 10. So this is 10 log 10 squared, which becomes 10 times 2 times log 10, but this is base 10, right? So this is just 20 and the unit is decibel. So when you hear this decibel thing for sounds, that's basically what it means. Like 20 decibel means that the sound intensity is 100 times I naught, which is the most, like the smallest, like a whisper or something even smaller than something. Like if you go below I naught, you can't hear anything. So I naught is like the threshold where you are able to hear something. And anything 100 times louder than that is said to have a decibel of 20. Now to double this, to get a decibel of 40, you can't have 200 here. Yeah, you actually have to have 10,000. So sound doesn't work linearly. Yeah, it works on a log scale. Just as common logarithms, we have one special case when e is the base, and then it's called natural logarithm. And again, we write in short form, we write ln, natural log. Okay, so log base e is shorthanded to ln x. So if you see log without a base, the base is 10. If you see ln, that means the base is e. And in all other cases, you should have a base that is given. Example, find the domain of this function. So what we know is that the input must be greater than 0 for log functions. So 4 minus x squared must be greater than 0. Now this you can factor, difference of squares. This is from 103 where you have polynomial inequalities. You find the critical points. The critical points are negative 2 and 2. And you pick a test point. So I pick 0 here, and I pick 3 here, and I pick negative 3 here. And then I plug in negative 2 minus negative 3 times negative 2 plus negative 3. So this is going to be negative 2 plus 3 times negative 2. So positive, negative, this is going to be negative. When I plug in 0, 2 minus 0 and 2 plus 0 is going to be positive. So it's negative here, positive here, and you can try it out, it's going to be negative here. But what do we want? We want it to be positive. And where is that? That's happening here. Which means that the domain is negative 2 to 2, none of them included. Why? Because if I include negative 2, then I'm allowing my input to be 0, and log of 0 is not defined. Log of 1 is 0, log of 0 is not 1, log of 0 is not defined. So the domain is this, and you can check. As long as you pick numbers between negative 2 and 2, 4 minus x squared is always positive. Similar problem, find the domain of this function. If you want, you can try to pause the video and try this on your own after looking at this. But essentially, x minus x squared greater than 0, x1 minus x greater than 0, critical points x0 and 1. Then you pick test points. Let's say I pick -1, and then I pick 1/2, and I pick 2. And -1 times 1 minus -1 is -1 times 2, which is negative. So negative over here. 1/2 times 1 minus 1/2 is 1/2 times 1/2, which is positive. So it's positive here. And 2 times 1 minus 2 is 2 times -1, which is negative again. So where is it positive? It's positive right here between 0 and 1. So the domain 0 to 1. And you don't include 0 and 1 for the same reason. If you plug 0, 1, it gives log of 0, which is not defined. So that's about it. That's the end of all the material. Exponential log functions, sort of things that you've seen in 103, 135. And the reason I put it in the end is because in calculus you will be working with logs and exponentials too when you learn derivatives. So you need to know how to work with them. So hopefully it remains fresh whenever you take Calc 1. Alright, that's it.